Hi, this is a recording of the webinar that we did for NCS4 the other day. Just thought that I'd record it in a high resolution mode rather than take it from screen grabs. Anyway, hello, my name's Keith Still. I'm a professor of crowd science at Manchester Metropolitan University in the UK. And just to give you some idea of my initials, FEMA stands for Fellow of the Institute of Mathematics and its Applications. FICPEM is the Fellow of the Institute of Civil Protection and Emergency Management. SFIIRSM is Specialist Fellow of the International Institute of Risk and Safety Management. MEWI is Member of the Expert Witness Institute. And FIPM is Fellow of the Institute of Place Management. My PhD was in crowd dynamics, which is an interdisciplinary topic which covers both mathematics and psychology. So I was programming and developing code for agent-based movement in large-scale interactive systems and developing crowd simulations back in the early 90s. So for over 25 years, I've been working with crowds, studying crowds, analyzing crowds, looking at accident and incident analysis. My PhD was crowd dynamics, so I have a lot of experience, and I've been working on some of the world's largest events. Olympics, Royal Wedding, and Saudi Arabia, 3 million people during Hajj. I was special advisor to the Saudi government for 10 years or so, on and off, from about 2000 to about 2010 or so. Small events, well, my local fireworks display, the 500 people that come to our village. The main difference is, of course, they know where I live. I've worked at the UK Cabinet Office Emergency Planning College, a lecturer there, developed crowd courses and workshops for crowd safety for major events. So for over 15 years, I was a lecturer, teacher, associate director. Everything associated with crowds has really been my focus. So teaching and training, as well as consulting. I generally take on consulting projects that help me improve understanding of crowd dynamics to help better inform teaching. So these two kind of go hand in hand. I've done work around the world: UK, USA, Australia, Netherlands, Singapore, Hong Kong, Saudi Arabia. Quite a lot of work across Europe. So, you know, I have 25 years of doing this sort of work. An expert witness. I've testified at the Senate House Committee on the Cessna incident in 2005 for the evacuation of the Capitol buildings. Did some work for a personal injury case in New York State. Currently working on a personal injury case in Chicago. I've done work on advising on the Duisburg Love Parade, on Hillsborough. Currently got a case coming to court when I'm testifying in London for another major event, personal injury. Now, what's interesting about working as an expert witness is that, again, that helps better inform crowd courses, crowd training, because knowing how things fail and how people get prosecuted has helped me develop better methods for teaching people to try and avoid this from happening in the first instance. So hand in hand, the expert witness, the consultancy, all go towards my main focus, which is teaching and training. And I run short courses around the world. I've done a lot of work in terms of citywide planning: Saudi Arabia, Liverpool, Liverpool International Music Festival, Matthew Street. Did some work in Distortion in Copenhagen, Austin South by Southwest. So again, a lot of experience on working with large-scale events in built and complex spaces. Now, primarily, we provide training and education. I've got a foundation degree module at level 5, which is called The Introduction to Crowd Science, and there's a book that's available from Amazon on this particular topic that introduces the crowd sciences. I've got a level 6 module, which is at BA Honours, which is called Applied Crowd Science. And I'm currently developing, teaching, training, and putting online, because this course is 100% online, a master's program at Manchester Metropolitan University. I run a 3-day short course, which is a bridging link from industry experience. It's called Acquire Prior Learning. So if you have industry experience, you do the short course, which is kind of half of the first unit on the master's program. And it's a combination of the level 5, level 6 programs. So really taking the existing training courses, which are university accredited, and put them together so that if you sit the 2-day course, then you've got an option of going down to do an events management degree or a direct entry into master's program if you complete 2 written pieces of work. So in other words, you're demonstrating that you've got the capabilities of taking on the topic, the master's program, and being able to keep up with the work pace. So really, the Masters is all about academic excellence, no substitute for knowing or being in the position of managing crowds, but can take experienced crowd managers and give them a lot of the robust theoretical underpinning that make them better in their job. As I said, everything that I do is university accredited learning programs. So there are a lot of programs out there that people who have a bit of industry experience set themselves up as teachers. I've had 25 years of theoretical work, field work, working at events, being a tactical advisor at events, designing and managing places of public assembly, built large complex environments, and everything I do feeds back into teaching and training. So my primary focus is teaching and training, and everything else helps augment that. So why do we need this? Well, there's a history of major incidents, and crowd dynamics fundamentally is poorly understood. So what we're trying to do is establish standards and professional qualifications. I work with the university, obviously the International Institute of Risk and Safety Management, and with NCS4 in America, where we're developing teaching and training programs to be to a worldwide standard. And the reason for that, if you just take a look at this list, this is not even the entire list of the incidents that have happened since I started in the industry. So over 25 years ago at Hillsborough in the UK with 96 dead, 400 injured. A lot of mass fatalities, a global phenomenon, and in analysing past accidents and incidents and looking at what gave rise to the problem, what gave rise to the incident. In other words, the underlying or fundamental causality. That's one of the things we tend to explore to great depths, is drilling into this disaster database. What is terrifying is that for every recorded death, fatality, or injury, there are unrecorded numbers requiring first aid and an even higher number of near misses and unlimited and unknown unsafe acts. We find a lot of people, because the events industry doesn't need any formal qualifications, anybody can set themselves up as an event organizer, apply for a permit, and then be in charge of people's lives. If you look at any other industry that involves an interaction with people, there are professional standards, qualifications, rigorous quality assurance standards, permitting and licensing. In the events industry, it's not there yet, and we need a lot more work to try and put the same sort of engineering standards you would have in any other industry. So if we take the airline industry, for example, a near miss, an incident that had the potential to become a problem, would be recorded, analysed, new processes and procedures would be put into place. In the events industry, a near miss is never talked about, never recorded. Nobody wants to own up to the fact that we had a close call. And when I run courses, and I run maybe 1,000, 2,000 people a year through courses, I always ask the first question in the class: how many people here have had that experience of, at the end of an event, sitting back and going, phew, we were lucky that time? And then done nothing about it, not recorded it, not implemented it. And of course, what you find is a lot of people have experiential knowledge, information that they'll gather and keep in their heads, but it doesn't necessarily translate to best practices in other parts of the industry. So one person's mistakes and errors and near misses and close calls don't get recorded, don't get documented, that knowledge doesn't get passed on, and therefore it's lost. We don't improve. And this is one of the fundamental reasons why we're trying to establish teaching and training standards throughout the industry and professional qualifications. So what is a near miss as far as a crowd's concerned? Well, here's an example from London Underground in the UK. To prevent overcrowding on the platforms, they shut the turnstiles, but then that develops crushing at the other side of the turnstiles as the crowd's coming in and can't go any further forward. So we end up with what's called a near miss, a close call, a potential crush that hasn't happened yet, a problem that's lying in wait. And I liken this to the analogy of, imagine you have an egg and you're going to try and push it back into the chicken. Now, what that means, as far as a crowd's concerned, is that we reach this level of critical density. So anything above 4 or 5 people per square meter has a risk. You can imagine if that has any individual in that crowd were to trip, slip, or fall, they would be crushed, they would be trampled under feet, there would be serious injuries. The mere fact that it hasn't happened yet is one of the issues that we're trying to address as far as crowd safety is concerned, and this is called the black swan theory. The conditional bias that we have is if we go and imagine this site that we're looking at, well, there hasn't been an accident yet, and therefore the operators would look at it and think, well, okay, it seems to work, and you develop a conditional bias. You tend to look at those situations and think, well, if it hasn't resulted in a serious injury, then it's okay to carry on like that. But we have a problem lying in wait. We have a high-risk situation that the more times you run it, the less likelihood that there is for you to perceive the underlying crowd risk. Now, I think this is probably best expressed by a quotation from Simon Bolivar, who says, "Judgment comes from experience, and experience comes from bad judgment." So it's not until a situation like that goes wrong do people then realize the enormous risks and how close that type of environment was to what we call critical collapse or progressive crowd collapse and somebody being seriously injured. So if we actually go back and have a look at the history of accidents and incidents, there are some common underlying features. I call this the DNA of crowd accidents. What were the characteristics that we could possibly identify? So again, this isn't the entire list, but if we have a look at it and start to differentiate, we'll pull out in red those incidents that could have been identified if we could calculate the crowd flow, the crowd capacity, the safe holding capacity, and set a limit on it. If we know that you can only get X thousand of people in that space, as soon as we get to X thousand and more, there's going to be a problem. So what was the limit? And this is about the mathematics. This is actually being able to calculate the geometry, the flow rate, the safe holding capacity, the volume of people that are moving into, out, and around of complex spaces. And we tend to find that the majority of incidents have either a design-based failure, so the design couldn't cope with the demands that were being placed on it, too many people, not enough space. Or there was an information change, a sudden downpour of rain, a handing out of tickets, a change of PA announcements, a late goal, for instance. So the information in the environment has changed and it's caused the crowd to react. Rarely we see incidents which have just been bad management. And again, this points back to our black swan theory, is that crowd managers generally are very good at reactive situations. Identifies a problem and then trying to fix it. And of course, that is not the work that I'm involved in. It's more about proactive analysis, is analysing the environment, analysing the risks before they develop. So we tend to teach and train people of what accidents and incidents look like, how quickly they can develop. And we did notice that throughout the research, and again, it's gone back through 100 years of records and incidents, the information that we can gain access to, was that primarily it's when the crowd's on the move, ingress and egress. So this lent itself to a model, what we call the demise model, and it's not by accident that it sounds like demise, but demise, design, information and management, the three primary identifiable DNA of accidents and incidents, and ICE, ingress, circulation and egress. So this particular model is designed to collect and collate information about crowd risks, allowing people to quickly annotate a diagram. We'll show you the table in a second, to compare and contrast events, to look at how a continual improvement process we put into place, and also to act as an event planning and permitting template. So here's the template. All events fit into that category, but it forces people to think about ingress, design, information management. So what's my ingress design? How do I inform people about where it is, how it's used, how it operates, how it functions? And how do I manage it? So under normal conditions, the top box there, the first column, in design information management, a brief notation in there about what it is, how it works, how it operates. And then in an emergency, how do I break that design to clear the crowd that might be queuing on the way into the venue? How do I inform the crowd as an emergency? And how do I manage the process of clearing that space? So ingress has its own contingency plan. Circulation mid-event has its own contingency plan, and the phase of egress has its own contingency plan. What's important about this is that I often look at event plans and only see in the event of an emergency, we will evacuate through the following exits. But what about if the emergency occurs as the crowd are coming to the venue? That's a very different management situation to the emergency happening mid-event. It's also a very different management scenario to what happens if there's an emergency as the crowd are leaving the venue. So a trip, slip, fall, accident, or crowd crush while the crowd are moving. How do we respond? How do we react? How do we identify that? And this is what it looks like. These 3 columns there are 3 separate dim ice models for 3 different venues. We then color code it. So it's a brief notation. And the couple of things you'll find about it is that if you start to put in ingress design, etc., if you've got a box that you don't know what goes in there, it shows you a gap in your knowledge. Because this is a generic framework for all events, it means that we can put information in there and identify those areas that we don't know much about. So it forces a structured thinking. And also, for a permitting officer, it will make sure that they've got a checklist that they can see that all of the components of the event plan, the crowd management plan, have been fulfilled. So we teach licensing officers, permitting officers, to look at this and say, right, what's the design during ingress? Yep, they've considered that. Well, what about the information during ingress? Signage, information, wayfinding. Yep, they consider that. So they can use it as a checklist, a tick box, if you like. When it's color-coded, then of course red means things we must improve. Amber are the things that we think we do right, but we need to monitor. And green, stuff that we're pretty confident that it's all okay, and therefore we never need to question or scrutinize. So your eye immediately gets drawn to those areas that are red, things that we must improve for the future. And of course, this now becomes a little checklist, a little color-coded box for quality assurance, for improvements for the future. So the dim ice meta model, the risk analysis, if you want, is actually looking at the dynamics of crowd risks, and also creates a template for us to develop a structured crowd management plan. So what happens if there's an emergency during ingress? What happens if it's an emergency mid-event? And what happens if it's an emergency during egress? 3 very different contingency plans. If the crowd management plan does not have all 3 elements, it's not fit for its intended purpose. They have not considered the overall risks, the overall dynamics, and that would be a basis for a licensing or permitting officer to reject that plan outright. So there's a risk template. It doesn't replace everything. It helps us augment and visualize crowd risks in terms of phases of behavior, ingress, circulation, and egress, and influences on behavior because the design influences the crowd behavior. The information will influence the crowd behavior. And finally, of course, your management style, your process, your procedures influence the crowd behavior. So it's a method of looking at how we can influence the crowd during those 3 phases. So design, information, and management, ingress, circulation, and egress. A comprehensive little model that helps us put structure to a crowd management plan. And with structure, we can apply quality assurance standards, and we can determine acceptable criteria for good, bad, or indifferent crowd management plans. Another thing we tend to look at in our courses is the difference between static and moving crowds. So defining what a static space, where the crowds are predominantly standing, what a dynamic space is, how the crowds move and what spatial requirement a crowd has, what contingency spaces we need for an emergency situation, and the demographics, how different types of crowds, different crowd compositions have different space requirements. Backpacks, buggies. In Australia they have eskies, which are big coolers full of beverages. So again, the spatial requirement of the crowd, we have a number of concerts in the UK, for instance, outdoor concerts where they'll take tables, chandeliers, chairs, picnic hampers, etc. So understanding the demographics, the crowd composition, vital to understanding how your space is going to be used. And with that, we tend to look at what's called ramp analysis, where we look at the routes, the areas, the movement of the crowd over time, and the profile, the type of crowd and type of crowd behavior. And the best way to illustrate that is show you a couple of examples. So here's a parade through a busy city centre. It's a football victory parade for Manchester United in this instance. There had been an incident back in 1999 and the parades have been cancelled, but they wanted to start running it again. They were asked to look at it. So that's the route of the parade. And if we have a look at the route itself, but now we look at how people get to this. It's going to be on a Monday morning on a bank holiday. So predominantly there's no commuter traffic. This will be people coming in just for the parade. So let's have a look at the stations. There's one down at the stadium. Then there are a couple darted around the site. But if we take how are the crowds going to get to this parade? We'll look at the route from the station to the parade. Now, what's going to happen is we're going to have two sets of barriers, one either side of the road. Crowds beyond the barriers, vehicles in the middle. And they're going to try and use as much of the road as possible. So 1/3 of the road will be barriered. You have 1/3 to the left for the crowd of the road, 1/3 to the right of the crowd for the road. But most of the transport facilities are here on the right-hand side. So when I was asked to look at that, the question was, how are you going to get people across to the left-hand side of the parade? You need to break the barriers. You need to fill the left-hand side first and then the right-hand side. You've also got a section of the road where there's no immediate rail access. So we're not going to have an even distribution of people across the whole route. The way in which people get to the site will dictate the higher concentrations of crowds in key areas. So understanding that gave us a better method of developing a crowd management plan. And finally, of course, there's a train station right next to the stadium, which works perfectly well in conjunction with the geometry of the stadium. But we're going to have people on the streets, and now we're going to have a lot of people moving down to a railway station, which would normally be controlled by geometry and management. So we shut that station down and said, no, people go to the stadium, they can go via car, and it makes a much more controllable ingress, and therefore we can control and regulate egress. We look at areas, and we have Google Earth Pro, and we've also got a 3D tool that allows us to analyze space, calculate area, calculate perimeter, look at barrier configurations. So, and of course we then subdivide that down to static spaces, spaces where the crowds are going to be moving, and we have a different spatial requirement for that, and also where we might need contingency spaces for emergency vehicles or treatment. And then we can have a look at movement. So this is the movement of crowd over time. This is for a football stadium. We were looking at how we might inform the crowd to get them to come in early. So again, this is just looking at data, looking at information, looking at the rate at which people move through space over time. And finally, profile of the crowd composition, demographics, the history of the crowd. It's putting together an idea of what do we know about this crowd, what is its profile, what's the previous history of accidents and incidents, what type of crowd have we got, is it a sporting crowd, is it a football crowd, is it a baseball crowd, a concert crowd. They'll all have different psychology, behavior, etc. And we can categorize that. There's quite a detailed study we can put into here. Not much that I can cover in just a few minutes on this short presentation. We tend to look at crowd profile, we'll look at the crowd composition, a lot more depth. And then queuing systems, obviously very important to understand how quickly we can process people through queuing systems, how to design safe queuing systems, what type of information requirements the crowd has in a queuing system. So very important we put those elements together so that we treat queuing as one component that we'll run in our teaching and training programs. Most importantly is risk analysis and risk management. So we talk quite a lot about the public perception of risk and our professional perception of risk. And again, this is where confirmational bias comes into play. The more the public interacts with something and doesn't come to harm, the less likely we are to perceive that as a risk. The risk doesn't change. Trip, slip and fall in our high density environment can result in fatalities. But we've run it like that 40 or 50 times. An incident hasn't occurred. You get this confirmational bias where you think that it's all okay. And this is again back down to where the black swan theory comes into play, where we try to analyze the likelihood, the consequence of something going wrong. One other important thing is when we look at the conventional risk assessment process, a lot of information is lost. And how do we get that information back into a usable form? Well, we use a technique called risk and congestion mapping. It allows us to map the congestion on site over time. And we've got ingress congestion, circulation congestion, and egress congestion. And when you map that, with the routing diagrams, you then again visually start to see where crowd management strategies come much more to the fore. Another topic that we cover is emergency response analysis. We look at how to optimize resources and response times, how to test response times, and how to develop what's called a risk-adjusted response time. So it's not about traveling to and from the incident, but it's getting closer to those areas that have higher risks. Again, this is understanding crowd risks in built and complex spaces. And we focus a lot on event and site design and how to manage sites. So techniques that we use there are differential spaces, where we embed information into the environment. We'll look at crowd flow analysis. We'll look at wayfinding and what's called situational awareness, how people are aware of different types of things in different types of environment, which is very important when you're looking at crowd monitoring. We've got techniques that allow us to shape crowd behavior. I tend to, when I'm working with computer simulations, not focus on trying to predict human behavior, but what do I need to do to influence it? So design, information, and management being those three tools that influence crowd behavior. And with that in mind, how do we best then monitor crowd movement through built and complex spaces? Well, back in 2000, so 17 years ago, I wrote the specification, and a gentleman that I was working with actually programmed this in Excel, a crowd condition monitor for the Sydney Olympics. And there it is in the center of the screen. The model's running. They can see what they're expecting, the prediction. They can see what's happening, and they can red flag if something is happening that wasn't predicted, something's going off plan. So we need to be able to get that information back into a control room environment in real time. And that's very important, because a lot of the work we tend to do before the event, this proactive analysis, is in crowd simulations. And again, I run a module here that focuses a lot on the difference between science fiction and science fact, what we can and can't do with crowds, particularly about crowd density and risk analysis, how to use simulations for safety cases, the good, the bad, and the downright dangerous, and how to apply the technology for value engineering, how to get the most bang for your buck out of complex spaces, particularly when you need to first and foremost focus on risk and efficiency, but also think about cost effectiveness as well. And for that, a whole range of tools have come out called decision support analysis, which are basically management analysis techniques, cost-saving techniques, looking at effective communications, and again, risk and resource analysis and deployment. And here's a couple of examples. This one saved some $50,000 off a budget, looking at the cost, which effectively is how I deploy my resources, which people need to be in which key locations. So rather than have all my team at all locations for all time, I need to focus the concentration of my effective resources for crowd management in those pink areas, the amber areas. So red, amber, green, again, very simple color coding. But across the top, we've got time. Down the side, we've got location. In color, we're showing the risk profile by area. So crowd density, crowd movement gives me a better idea now where I need to do crowd management. So again, I don't need all my resources spread across all the site. I can be far more flexible and far more effective. Looking at interprofessional communication is another technique that we've been developing, where I can look at different groups. Here we've got the event operating control, talking to the police, talking to first aid, talking to security. The method of communication is the words in the box. The effectiveness of communication, red, amber, green, gives us an idea of where we can make communication improvements. Very important when you're looking at incident location and response. So we've got different type of incident related risks across the top. We've got locations down the side. We've got potential crowd reactions in the words, and the effectiveness, the impact in the color. So again, a very important technique that we tend to work with people in these courses. They'll come along for 2 days teaching and training, and then 1 day where we will work with our expertise to develop a better understanding of how to apply the tools to your site. So the course is designed around formal teaching, training, standard and qualification, teaching you how the tools are used or how they've been used historically. And then we spend day 3, which is just about, right, how do we apply this to your site? While it's fresh in your mind, working with you, it's kind of like a 3 days consultancy, but we're really facilitating using that knowledge and experience, using those tools on day 3. Here's another example of a similar sort of model, but here's looking at 4 different bits of information. So movement, 1, 2, 3, low, medium, and high. Color for density, low, medium, and high. So we can see the numbers, the colors, the location, and the time in one chart. That gives us an enormous amount of visual information that would be very difficult to describe in words. And quite a lot of the work that we do is focusing about how do crowd managers communicate with each other. So understanding the level that they need to pass complex information across and designing tools that allow that information to be communicated with the minimum amount of words, because if you have to spend all your time trying to describe this in words, it would be very difficult. But putting it into a diagram, in a model, in a chart, is very easy. So it allows the team to take the collective experience and to crystallize it in a form that's then easy for other people to pick up, act upon, modify, enhance. So this is all about understanding how people communicate in the industry, how to capture that information and how to pass it across within the interagencies so that we're all seeing the same picture. And that becomes vital when we start to look at emergency situations. So one part of our course talks specifically, looks at behavioural-based safety, how people behave in normal and emergency situations, the crowd and staff reactions, and we look at emergency scenario analysis, where instead of having a book of scenario response, scenario response, scenario response, we turn it on its head. We say if we need to get the crowd away from relative danger to relative safety, there are only 2 methods of doing this: move them or keep them in place, which is the safest option. So having a decision tree in a control room has grossly reduced the amount of work that people need to memorize and act upon. So these are the tools, or at least some of them, as much as I can show in this short talk. And what we do on day 3 is basically teach people how to use the right tools, the right application at the right time. Now, the focus of all of this is towards quality standards and improving our knowledge and information within the industry. The problem we find, you see, is that people will have knowledge, will have experience, and then they'll move to another part of the city, the town, another country, and that knowledge of how that site works goes with them. It's never captured. So a lot of these tools are designed to capture that knowledge and information, which is site, event, crowd specific, to break it down into its component parts. And once you've done that, you generally tend to find that you have got a unique set of circumstances, a unique blueprint, if you like, for that specific event. Now, we had on the webinar questions and answers sessions. Somebody asked if I've not seen an event before, if I've got no knowledge of my crowd, can I use these tools? Absolutely, that's what they're designed for, to fill in the blanks so that we don't head into these environments. We don't dash off into the horizon with the unknowns. So if you want to ask questions, please put them forward on email, get in contact via NCS Forum or myself. My website is gkstill.com, and that's the support website for the teaching, the training materials. So we've got a lot of reference documents, a lot of reading material on there, some video clips. So that's really our repository of knowledge. Well, thank you for listening. I hope you've enjoyed it, and this gives you maybe a taste of what you can experience over the 3-day course. 2 days teaching, training, application, where we do lecture application, lecture application, lecture application, and then on day 3, it's all about your work. You come in with a case study, you come in with your material, and we'll work through the tools with you to show you which tools apply in which environment. So what's fresh in your mind, you can actually use that set. Have a look at my website and have a look at the client quotes. You'll see the work that I've done around the world, and you'll see the feedback that we've got. And again, these are university accredited programs. This is not something I've just slapped together. I've been teaching this for nearly 2 decades now at universities and also in the field. I've worked with clients around the world. I've been an advisor in Saudi Arabia. I worked with Olympic events in Australia, UK, and in Beijing. I've looked at and worked with big designs, big environments, big city centres. And again, down to the small events, the 500 people that come to my fireworks display. I take this very seriously, and we put a lot of passion and effort into the courses. So do please come along, have a chat with us. Talk to us via email. Always happy and willing to answer questions. Well, I hope you've enjoyed that. Thank you very much for listening, and we hope to see you soon. Bye.